then here's how you were supposed to come up with that. And I gave you just a touch longer on this one because there's really two things. You got to figure out where it's decreasing. So, first derivative, make sure you do chain rule. And then we can use that to say, all right, this stuff equals 0 at 0. 0 is a critical number, and even though there's an x in the denominator here, this never is 0, because this is always positive. You add 1 to it, this is always going to be positive, so it's never going to be 0. Plug in a number into the first derivative to the left and right of all the critical numbers. You get positive here, negative there. So now I can tell that it's decreasing from negative infinity to 0. But that's not the full question. It wants to know where is it decreasing and concave down. So I also have to figure out the concavity, which means I'm going to need the second derivative. So to take the derivative of this guy, unfortunately we're going to have to do quotient rule. So derivative of the top with the bottom left alone minus the top left alone times the derivative of the bottom, all over the denominator squared. So not too bad actually. And then before I start trying to figure out where that equals 0, I'm going to try to simplify as much as I can, combine some like terms. And then if you set this denominator equal to 0, he's always going to be bigger than 0. The smallest you can make this be is 0, because anything squared is positive. Add 1 to that, this is always going to be positive. You square it, it's always going to be positive. So this is never going to be undefined. But this, the numerator does equal 0 sometimes. Subtract the 2 over, divide by -1. Take the square root of both sides, which is plus or minus. And since these are where the second derivative equals 0, these are possible points of inflection. So test maybe 0 into the second derivative. See that you get a positive value. Maybe plug in -2 into the second derivative. It's something negative. Maybe plug in 2 into the second derivative. You get something negative. And now we can start to find our answer here. He's decreasing from negative infinity to 0, but he's concave down from negative infinity to -1 and 1 to infinity. But where these two things overlap, the only time that both of these and is from negative infinity to -1. It's the only place that both concave down and decreasing. So kind of a 2-for-1 there. Alright, so a little bit more going on. Any of that I went through too fast that you need to speak up about?